Good morning. Good morning, good day, everyone. I hope you're healthy and navigating these complex times as best you possibly can. And welcome to part two of the Pluralsight and AWS DeepRacer series. Today, we're all about reinforcement learning and refinement. In our time today, our speaker, Tim O'Brien from AWS, is going to walk us through refinement and reinforcement. But to ensure we're on the same page, he's going to, step through part one and set the stage for us. Then he's going to go into a deep dive into building our first model, how to speed things along to make them go faster, provide you with some insider tips and tricks. And then we're going to conclude to my favorite part, the Q&A. So again, I'm Amin Martz, Director of Strategic Partnerships and Alliances at Pluralsight, and I'm really happy, I'm incredibly excited to introduce Tim O'Brien, Senior Solutions Architect at AWS. Tim, over to you.
Thanks, Amin. Hi, I'm Tim O'Brien, broadcasting to you from sunny Santa Clara, California. We're talking the second of a series of DeepRacer, and what we're going to do today is dive a little bit deeper into reinforcement learning and how you refine your models. So let's recap. What is DeepRacer? DeepRacer is a 1/18 inch four-wheel drive scale model car with Ackerman steering. It has an Intel Atom processor, a full Linux Ubuntu operating system, a stereo camera, and LiDAR. And you can actually hook up a monitor, a keyboard, and a mouse to that machine and program it just like you would in any other Linux operating system. And in fact, sometimes in advanced kinds of actions, we can actually log right into the car itself and actually do some programming on it. And the goal of this is to make it go around the track as fast as possible. And also one of the goals is to really have a lot of fun. So the car is your agent. The goal is to finish as quick as you can. And we have rules, of course. Some of those rules are things like you only get to reset the car 3 times. If it goes off the track, the 4th time, we have to take it back to the starting line. So what you do is come up with various kinds of reward functions. This car doesn't know anything when it starts. And the reward function is something you program and you tell it what kind of behavior I'd like to incentivize. Now in this particular model, what we're talking about is centerline driving. So you can see the purple means the car has gone off the track and we give you no reward for that. If you're close to the center line, we're going to give you 2 points for every stage that you move through. And if you're a little bit closer to the sideline of the track, we're going to give you 0.2 of a point. And so as the car goes along, you'll see that it tries various kinds of actions. You know, from one state to the next, it'll gather points for the reward function. And then hopefully over time, as you're doing this exploration of the entire space that you're traveling in with the car, you can start to converge on the right answer. And it will try lots and lots of different paths until it finally gets to the point where the car is actually going to finish. Once it's finished completely in its training, which we call exploration, you'll then want to exploit it. So you'll download that model and you can either put it into a virtual car on a virtual track, or you put it into a real car for a physical race. And we go through what's called exploitation, or in the industry, what we call inference. And you can see that it keeps trying, and you can note that the clock counter occurs. And there's 2 counters. One is the 3 minutes you're given to actually complete an entire lap, or if you do multiple laps, that's even better because you have a chance to go faster and faster as the car stays on the track. And like I said, we'll reset it 3 times and go back to the start line on the 4th, or we'll put it back on the track for each one of those resets. And in the 4th reset, we actually have to start you over. And I'll share some tips and tricks later on what elite racers do with their cars when they're actually physically racing. The basis of the DeepRacer is reinforcement learning algorithms. And we use something called vanilla policy gradient. And what it does is it gathers information at each state as it's going around the track. and it tries to maximize the cumulative rewards that it's gathered so far. We use a multiple layer neural network where the input layer would be the camera, and the camera shooting 30 frames a second. We sample half of those, so we process 15 frames a second, and that's the inputs of this car. And of course, it's a grayscale, so things like bright lines on the track or dark pant legs would really matter, so we try not to stand in front of the camera. And then it goes through these hidden layers and readjusts weights as we're going along. And then finally, the output would be how fast am I going, what steering angle do I use, and hopefully the accumulation of all of those activities will get you around the track in a winning time. The neural network architecture looks like this, like I talked about. The input is the camera. Now, it's a grayscale camera, so it doesn't look exactly like what we see here, but what it does is it captures all those pixels, and then it goes through a convolutional neural network to extract features like the track border, the center line waypoints, and what the infield and outfield of the track look like. When it's all done extracting those features, it feeds it into a policy network, a second neural network, and that policy network adjusts the weights so that it can actually have appropriate actions, as I mentioned, going forward fast or slower, and left or right turns. Here's the track components. We have a track wall, which is a Pantone blue, and that is not something the camera actually sees. You and I can visually inspect it, but the camera won't see that. It's just, you know, blank to it. There is green for both the infield and off track to the outside. And then we have those white lines, which are the track boundaries. And technically the track boundaries are still part of the track. You'll see that there's a black part of the track with the yellow track center. And of course, the car doesn't really see the yellow lines. It just sees a different kind of grayscale. One of the rules for DeepRacer is that when we say, it's like in soccer, the hole of the ball across the hole of the line. If the car is in the infield or the outfield of the track, that means that all four wheels are completely off the white lines. If one of those wheels is barely touching the white line, the car is still on the track and it wouldn't have to be reset. So now let's build our first model. First thing you're going to do is you're going to log on to the DeepRacer console, and you're going to navigate to the DeepRacer service. You're going to go to the garage, and you're actually going to build a vehicle, because when we start, you don't have a vehicle. So you, just like you pull into your garage, you want to get out all your tools and build a vehicle for yourself. Then we're going to create a model, which involves generating a reward function. We're going to train it, and then we're going to evaluate that model. And then later on, we're going to race, which is the exploitation of that model that you've already developed. So that's the agenda for today in building a model. So here's the DeepRacer console. Log on to AWS console, navigate to DeepRacer either by typing DeepRacer into the console right here, or you can select DeepRacer out of the history if you've already gone there once. If you're in a different region than US East, North Virginia, you might get a message like this. And if that's the case, just click on the link there and it'll take you to the appropriate region, which is in North Virginia. That's the only reason where we support DeepRacer right now. First time you ever log into DeepRacer, you'll get a getting started image like this. And so what you'll do is you'll click on that getting started button and we're off to the races. So the next thing we'll do now is we're going to want to build a car. So if you want to learn a little bit more about DeepRacer, we actually will have a workshop that you can attend, or you can click on that Start Learning Reinforcement Learning button, and that'll give you a 10-minute lecture on how to learn the basics about what reinforcement learning is all about. We're going to bypass that for today. You can do that on your own. You're also not going to click on the create a model right now, because the first thing we have to do before we create a model is actually create a vehicle. So we're going to navigate to the upper left-hand side of the terminal, and we're going to click on that, and that'll take us to building a vehicle. Then at that point, we're going to navigate to the garage by clicking on that link. And once you're in the garage, you'll see that there's already an original DeepRacer, but we're not going to use that. We're going to build our own. So we're going to, you can see, well, first, let me recap what you're seeing in the garage. It's going to show you how many sensors are involved. And in the classic DeepRacer, there's only a single sensor. There's just one camera. In one of the more advanced cars, the Evo, which we'll talk about in a couple of weeks with Greg Prisby's lecture, we're going to talk about other sensors like LiDAR and a second camera. But for now, we're going to use a single camera, and that's a good way to start. The neural network topology is going to be a 3-layer convolutional neural network. So you have the input layer, which is the image, feature extraction layer, and then the output layer, which is your action space. It tells you how fast to go and whether you turn left or right. You can see here that in the action space, this particular vehicle is slated for a speed of 1 meter per second. It will have a maximum steering angle of 30 degrees to the left or right. And then you can see the shell is the classic DeepRacer. And we're going to change all of those when we build a new vehicle. So click on that button in the upper right-hand corner, and we're going to build it. So you can see here for a classic DeepRacer, we're going to have a single camera. Just leave it that way for now. I will tell you that you can train actually a very good model in a couple of hours and, for the classic DeepRacer. If you go for the more advanced one with stereo cameras and the LiDAR sensor, you're looking at maybe a minimum of 9 hours. And that's quite a long time for a basic workshop. So let's leave it at that default setting of single camera. And then what will happen is we'll look at the action space. And the action space tells you it's a combination of steering and speed. So you can see here on this screen that our maximum steering angle is 30 degrees. And frankly, I never changed this because there are some of the turns in many of the tracks which requires a full 30-degree turn in order to navigate around the track. The next thing you want to do is select a steering granularity. I typically choose 5. And what that means is I can shoot anywhere from a left 30-degree turn, a left 15-degree turn, straight ahead for 0, a right turn of 15 degrees, and a right turn of 30 degrees. And so you'll have more flexibility in there. It takes a little bit longer to train with a larger action space, but that steering angle granularity is a big component of that. So let's leave it at 5. The next thing we want to do is choose a maximum speed. Now here it shows 1. I typically, for purposes of training, will choose something different, either 2, 3, or 4 meters per second. Again, it's going to take you a little longer to train, but it's going to give you more flexibility. And then I almost always choose a speed granularity of 2. And what you can see here, the action space of 0 through 9 means we have 10 different actions that we can take. And that's basically the multiplication of the steering angle granularity by the speed granularity. So you can see if I change the speed granularity to 3, that's going to give us an action space of 5 times 3 or 15. So there's more actions the car can take. It takes longer to train, but it gives you a lot more flexibility. So go ahead and choose 3 for the speed granularity and 5 for a steering angle granularity, and then set your maximum speed maybe at 2 or 3 meters per second. And because that 5 times 2 in this demonstration is 10, you can see there's your 10 different actions that you can take. Now let's talk about the steering angle and the speed for a second. You'll notice that in the top 2 rows, we have minus 30-degree steering angle, and we have a speed of 0.5 meters per second and 1 meter per second. What this is telling us is that we can slow down as we're going into a turn, much like a NASCAR or Formula 1 driver might do, and then we can speed coming out of this turn on a left bank of minus 30 degrees. So with more granularity, you have more actions that you can take with different speeds, and that makes the car a little more flexible at the cost of doing additional training. The next thing you can do is you can change the custom, your vehicle appearance. A while ago, we did a conference for John Deere, and of course, they printed up custom shells with John Deere tractors and stuff. We don't have quite that flexibility here, but you can change the color of your shell. And of course, I named my vehicle here, My Excellent DeepRacer. and I chose a blue just so that when you visually inspect it inside the garage, you can see that it looks a little bit different. Now you can see that once I save that, I have two cars, the original DeepRacer and then my excellent DeepRacer in blue. And that's the name of it. And there is all of the settings. So you can compare that to the original DeepRacer, and you'll notice that I still have a single camera. I still have a 3-layer CNN, but my speed is 3 meters per second in the action space. And my shell type is still DeepRacer, but it's a different color. After we've completed the vehicle, we're now ready to create our first model. So click on Create Model and we'll move on. And this is where the magic starts. Of course, we want to first give our model a name, and this is unique to you. You can only use a model name one time in a particular account. So you can name this whatever you'd like as long as it obeys the rules right down below. 64 characters, and the valid characters are lower and uppercase A through Z, 0 through 9, and a hyphen. You can't have underscores, you can't have spaces. And then of course you can put in any kind of job description you want for training. I typically would name these models when I'm building something simple and then maybe indicate how many hours of training I'm going to give per model in the model name so that I'm looking at them in the console, I can see what they are. And then I would provide a much more detailed description in the training job description of things like how many hyperparameters I was using, what was the basis of the reward function, and that sort of thing. But it's up to you, it's totally flexible. And of course, that job description is optional. Now, the next thing you have to do is choose what kind of a track you're going to train on. And of course, since reInvent of 2018, when the DeepRacer car was announced, we've developed lots of different tracks. For purposes of this demonstration, I'm going to continue with the reInvent 2018 track. It's basically mostly left turns with one small right turn there, sort of in the middle upper part of the track. Pretty simple track, but it's really, really good for training purposes because it doesn't take a long time to train for this. So I select that and I scroll to the bottom, and you can see that I've got other tracks that I'm showing, but all I want to do now is click Next and move on. Now, there are 3 different race types. I'm not going to talk about object avoidance or head-to-head racing because that takes many, many, many times more hours in order to do those. What we're going to do is a basic time trial. So you're racing against the clock at this point. So you can select the time trial, which is the default. And then the next thing you're going to do is hit that down arrow button and choose the vehicle that you just produced in your garage. In my case, it's my excellent DeepRacer. And when you're done selecting both of those things, you can select Next, and we can move on. And here's the basic, most important part of building a model, the reward function. Now, the reward function is, for those of you who are familiar with AWS Lambda, it is a Lambda function, and it's built into the console to make it really easy to use. And we provide you a number of different examples for reward functions. There's actually 3 for the time trial race and 1 for head-to-head. But right now, you'll see that we build a default reward function for you that follows the center line. And that's a real good one to start with just to get going. After that, you can modify it. And you can see this here is just 25 lines, including blank lines, in order to draw a good starting point for a reward function. And that's what we're going to do to test our first model. Now, anytime you do code up a model, you want to go ahead and click on the validate, because this is sort of a lint function in Python. And what it'll do is it'll check the syntax of your reward function and make sure it's proper before you save it and try to do training. The next thing you'll want to do is note that we're using the PPO algorithm. And there are hyperparameters, but for now, I'm going to ask you not to change any of those. The hyperparameters for the basic model were set by the scientists in our DeepRacer team, and they're generally very, very good to start with. The next thing you'll want to do is choose your stop condition, and this is basically the maximum time you want to train for. When you're first doing a model, you might choose something like just 30 minutes or 60 minutes just to see how the whole process works. And typically what I do is I choose something along the lines of 2 hours when I'm actually building a model that I think will actually work. I would strongly urge you when you're doing your coursework to unclick this, because when you're, if you leave it checked, like it's shown here, what it will do is as soon as you're done training the model, it's going to submit it to a virtual race. I like to practice on my own before I submit something to the virtual race. So I'm going to ask you to uncheck that. And then you'll click create the model. Now to recap, this is the reward function is built in a code editor we provide you 3 example reward functions for the classic DeepRacer. And then of course, there's a validation function over here that tells you whether the syntax of your Python code is correct. It doesn't say your model is going to work well, it just says the syntax is correct. So now that we have created a vehicle, we've created a model using that vehicle, now we want to train it. And training is that exploration part. And it takes the amount of time that you set up. You can see when you start up with your model, you're going to see that it's got a screen that looks very much like this. And when you click start, it's going to initialize, and it'll take about 5 or 6 minutes to actually build up the appropriate instance type in the background, load the software onto that instance, and then load up your model for training. Once that initialization period is passed, you see right here we're initializing, we will continue on with training and actually see something. If you want to look at your reward function while you're training, you can click on that show reward function button, and that'll show you so you can recall what your reward function was made up of. And you can also select the action space to say, oh, I can't remember what my action space was. While it's training, you actually look at both those things with a pop-up window. And then of course, the hyperparameters, which we did not change this time, but it lists out those hyperparameters that are coming by default. And you can see what those are here later. In a more advanced part of the building a model, you might actually tweak those hyperparameters and try to optimize how well your model does going around the track. So now we're training. And you can see on the right-hand side, there's a simulated video of a track using RoboMaker. And that car is actually going around the track. And during training, you'll see it actually go off the track. Sometimes they'll go off the track many, many times. And what it's doing is exploring that entire search space that you have. And on the left side, we see a reward graph. The green line being the average reward that we've accumulated so far. The blue line is going to show you what % you've been completing during the training. And then there's an evaluation component, which is kind of testing. You might consider it testing from a deep learning perspective. The red's going to show you what the % complete was once it evaluated. It's hopeful that the green line will continue to go up over time, not like this one where we saw it go up for a while and then goes down a bunch of times. That's not a really good reward graph. But then I didn't spend any time building this reward function either. And you can see that at the end of 250 plus iterations of training, I'm only maybe 6 or 7% of the way through the track, 12% of the way through the track. I'm not very far along. And my reward function, of course, isn't being very consistent either. When we're all done training, hopefully this car will make it around the track multiple times to completion, and we'll have a very, very good time. So you can see there's the average reward, the completion, and then once we're done, we're going to go through evaluation. So training will be complete. And the next thing we're going to do is just take that same model and click on the Start Evaluation button. And now when you evaluate, you can evaluate it against one of many tracks. Now, training, if you overtrain on one track, so you really train for a long time, and then you go to evaluate it, it might not work well against all tracks. So this is a good way to test whether you've overtrained a model, whether it's memorized kind of how to go around a particular track. But for purposes of this beginner part of the class, we're going to go ahead and evaluate against the same track that we did training on, a reInvent 2018 track. We're going to go ahead and still do time trial, and we're not going to submit we're going to do 3 trials, we're going to do time trial, and we're not going to submit the model to the qualifier. And we're going to start the evaluation. When it's all done with the evaluation, it doesn't take very long. You can see that this particular model was not a really successful one. The trial results told me that at best, I would have completed maybe 1/3 of the distance around the track. And of course, the status was I went off track in every case. So later on, what we're going to talk about is ways to improve this model so that it becomes much better at actually achieving our goal of completing a lap in world record time. So now we're going to talk about how do you go faster, and it's all about creating a much better reward function. Now, I'm not going to give you the reward function. You still have to do that work on your own. But what I'm going to do is give you some places to look on what you can study up to build better reward functions. There's really still, I'll refresh, there's 2 goals here. One is to make that car go as fast as possible, but the second goal, and the far more important one, is to learn something about machine learning so that you can use use this technology to solve real-world problems. So here's the tips and tricks I have for how to create a better reward function and go faster. The first thing you want to do is just while you're in the DeepRacer console, take a look at that reward graph. What is it telling us? Now this one, you can see the little gray swoop that I drew across the reward graph here tells me that my reward function isn't doing a really good job of sort of being even and generally going up and to the right. As we train and we're exploring, I would expect that thing to slowly get better, not go up and down wildly like it is here. So this tells me right off the bat that my reward function isn't a very good one. You can also see that as the reward goes up, you would expect your percent completion to go up as well, and at a rate maybe commensurate with how the green is going up. That's not the case here. So there's 2 indications that my reward function is not solving the kind of problem I want. So I need to start focusing more on improving that reward function rather than worrying about anything else. And sure enough, the proof is in the pudding here, because both on a training and evaluation perspective, I only got somewhere between 12.5% and 34% around the track, which is just terrible. You're not going to win at that. The next thing you want to do is consider the other parameters that are available to you. You don't only have to worry about speed and all wheels on track, but this is a list of all of the different parameters you can use. And if you analyze this, things like steering angle could be important, how much progress you're making around the track with the number of steps, how wide is the track? Do I want to stick towards the center car driving, where they come out of the turn wide and then come in narrow? You can consider all that kind of stuff. Do I want to do some trigonometry based on the closest waypoints? All of these are parameters that you can deal with, and every time you do a sequence in that lambda function. In some cases, you want to use more than just one parameter. You might want to use multiple parameters. And here you can see that I passed in I didn't pass in, they're always passed in, the parameters, but what I'm doing is I'm using track width and distance from center and what my steering angle is. And I want to take a look at my speed, how many steps and progress I've made. And then I want to calculate are all the wheels on the track. You can use all of those parameters and many more in your reward function. And you can see that this is a much more complicated one than the one we started with. And in fact, it's probably more like 100 lines long by the time I was done. Because this is basic Python, you can import certain Python libraries that are built into the DeepRacer learning framework. In this case, I want to do some mathematics. I want to do trigonometry on tangents and that sort of thing on the track direction and the waypoints. So I'm importing Python libraries, and you can see down here I use a tan2 function out of the math library. One of the final big tips is that in addition to looking at the reward graph, which is a crude way of seeing how well you're doing, you can actually study the logs. And what you'll see down here at the bottom of the training screen, you can actually download both SageMaker and RoboMaker logs. Now, the DeepRacer console is a nice, easy way to view and create models and then watch how you're doing in your various kinds of training and evaluation cycles. But you might want to look at the logs that are produced by SageMaker, which is our fully managed Jupyter Notebook service. And it produces logs that you can then download and look at so you can see, am I actually progressing around the track like I expected? Where am I going off the track? What was the speed at the time? So you can export all that data into the log capturing mechanism and then go visually inspect it, to look at the actual log code and see what does it look like and improve your reward function over time. Make subtle or even significant tweaks to it so that your reward function performs much better. This is what a log file looks like. So you can see that you can output all kinds of stuff that has to do with loss functions and how much entropy am I having at the time and how far I'm converging or diverging from my goal. And you can output all kinds of custom information into this as well. So studying the logs is a really important part of building a much better machine learning model. The other thing you can do, which is just throwing money at the problem, you can train for a longer period of time. In some cases, you'll find that increasing your training time can be very successful. If you train a model for 5 or 10 minutes, you're not going to get very far around the track, but that might prove that you're actually building a reward function to a positive nature. One of the things I can tell you is that last year for reInvent, I did a study with, I think, 16 different models. 8 of them are shown here. And what you can see is that I trained those same models, all using a basic single sensor vehicle. I trained those 8 different models for between 1 and 8 hours. And oddly enough, somewhere around 2 hours was the optimal training time for most of those models. And only after training for an additional 4 to 5 hours did I get results that were anywhere close to what I saw at 2 hours. So what that told me is, because of the way the models converged, I was actually overtraining for some period of time, and I had to throw another 4 or 5 hours of training, which costs money at this problem, in order to get a result even close to being as good. So don't overtrain. Overtraining just gets you overtraining. It doesn't buy you anything. It doesn't make the car go faster. It doesn't go around the track any better. It really depends on the complexity of the reward function and the action space. Okay, our final section is going to be tips and tricks. What do those elite racers do in order to make their cars go fast? The world record right now on the 2018 track is just under 8 seconds. It's fantastic. I got a chance to talk to those racers that were able to achieve that great goal. And here's some of the things we talked about. Again, I'm not going to give you the code for it, but I'll tell you where you can study up on it so that you can improve things. So the first thing they do is snaking. Now, snaking is a term that we use in our DeepRacer industry to talk about a car that oversteers to the left and the right rapidly. And sometimes if you build a reward function based on progress, the car will say, hey, by turning left and by turning right, I get more steps, and I'm going to go ahead and maximize my reward function for doing that. Well, you can imagine if you're driving around some NASCAR track and you're making lots of left and right turns, you're going to not only travel further, but you're going to not go as fast, because you can't drive as fast when you're making left and right turns. So we want to minimize snaking. The second thing we want to focus on is waypoints. Elite racers often look at waypoints, and you can see that the track, you won't see waypoints actually on the track. The waypoints are crafted by the car as it flashes its camera and takes pictures. And the waypoints are a fixed set of distance away from the car. And of course, they're a little tighter together when you're on a curve. But you can measure those waypoints using math functions inside your reward function. And waypoints can be useful in actually minimizing the distance you have to drive around the track. Much like a NASCAR or Formula One driver, you're going to want to minimize the distance you drive. If you drive the outer border of the track, of course, that's longer. If you drive the inside border, it's a little bit shorter, but it's not the optimal distance around the track. And that's what's called a racing line. So you can see there's the turquoise colored blue or teal on the outside, in the center tells you what the track looks like. And the red line is sort of an optimal racing line. It's the minimal distance that you can keep at speed going around the track. And what you can do is, using your log function, you can start to establish what that racing line will look like, capture that, and then model your reward function so that it minimizes that. We already mentioned log analysis, but this is a really important part of racing. And you can see here that by looking at the logs, I've captured how many points I've had at various places along the track, and I can see where errors are starting to occur. It also helps me start to develop that racing line. So log analysis can be very, very important for understanding what your reward function is actually doing at a refined level. And finally, hyperparameters are really important. When you get to the point where you have a very fast model, say under 10 seconds, what you might want to do is consider training the vehicle for some period of time, and then coming up with a slower learning rate. And the problem with using a low rate all the time is it may struggle to converge. It wouldn't converge very fast, and you'd have to train for a really, really long time. You also might find finite minima at various places, and so the learning rate's super important. But what I would suggest is you start with a moderate learning rate, and then maybe later take that model, clone it, and start with a learning rate that's smaller than what you used. The other thing I'll mention is there's a number of white papers that have been written about hyperparameter optimization. There's a number of reInvent talks in this area, and some of those are in the resources section at the end of this presentation, and I'll share those with you. But I also want to mention that hyperparameters typically are changed in pairs. So you might want to modify batch size, but you also might have adjust epochs in there as well. Or if you're going to change learning rate, you might want to change the discount factor. There's lots of discussion about which pairs of hyperparameters you'll change to optimize your training, and I'll let you do that research on your own. And then finally, if you want to escape the bounds of the DeepRacer console, you can go directly to SageMaker. And we actually have a number of notebooks that would describe both how to do log analysis using SageMaker, as well as actually training your car. The DeepRacer console is built to get people started with DeepRacer and machine learning. But of course, it has limitations. We want to protect people against overspending, so we limit how many different models you can train simultaneously and how many you can evaluate simultaneously. If you think you know how to manage that yourself, knock yourself out, build your training environment in SageMaker and do it that way. You'll have a lot more flexibility, more power, at some risk of being able to spend more money quickly doing training. I promised you some additional resources, and I've got a couple pages of those. I'll make sure that we get all of these to you in a written format so that you can look it up. But one of the things I want to call out is there is a huge DeepRacer community. So I'd urge you to join that Slack community on DeepRacer. The people out there are passionate about this, much like I am. And if you join, you'll be able to share tips and tricks with lots of your peer racers. Of course, we have AWS DeepRacer workshops and free video courses and all kinds of racing tips that you can find online. Some of the things I talked about earlier was, expert bootcamp videos, the Slack community, of course, again, and then any information you want to know about how do you build your own track in your basement. I've actually built a track in my garage, and a pretty common phrase, happy wife, happy life, comes to mind. I built that track just out of duct tape and sheets, and after a week I was almost kicked out of the house, so I can't recommend doing that, but you certainly can build your own real world track and have fun. And also, if you decide to really get into this, you can buy your own DeepRacer build your own DeepRacer track and buy your own DeepRacer car. And then finally, pardon me, I shared a number of additional resources here related to the things I talked about in the tips and tricks for the experts. And we'll make sure we get all these links to you as well. And now it's time for.
Hey guys, Tim, thanks. Thanks for taking us through the DeepRacer journey. So, as a quick reminder, everyone, use your Q&A button at the bottom of the screen to ask your questions. So let's kick off some of the questions that just came over. One of them is, what is the reward graph telling me?
So the reward graph is inside the DeepRacer console is a way of demonstrating what your average reward is over time. And it also shows you what the average percent completion is. And one of the things that I look for over time is to make sure that both my reward function and my average percent completion is going up. And as I mentioned during the talk, that the reward graph is a little bit of a crude analysis, but it gives you the first idea if your reward function is even close. Later on, you can do log analysis, but I almost always start by just looking at the reward function. If you are getting lots and lots of reward points, but the completion percentage is a whole lot less than 100%, you know that you've got a terrible reward going on and you need to retool it.
Makes a lot of sense. And this one just came over, so I'm really curious about this one. Can you change action space after you've trained a model?
Well, generally no. In the DeepRacer console, once you've created an action space, the shape of the neural network, the CNN, is fixed. And remember, the action space is the output layer for that network. So the answer would be no. If you clone that model, so you've built a model with a given reward function and you've trained it for a couple of hours, you now have a neural network with weights. You can clone that neural network, but you can't change the shape of the network. Both the input and the outputs are going to remain the same. Now, cloning is nice because then you can tweak hyperparameters. You can take it and train on a different track. You can change everything but the shape of it. You can even change the reward function, although I wouldn't recommend that. And what I said was generally no. So you can do interesting things with SageMaker. You could somehow clone that CNN in SageMaker and modify the action space, but I think the results would be kind of unknown. So if you had an action space of 10, which means you had a speed granularity of 2 and a steering granularity of 5, and you change that to be 5 and 3, you now have an action space of 15. What would the weights of those additional 5 rows in the action space be? It's undefined. And so I don't really know exactly what you get out of that. Would it converge quickly or would it take a long time? So we generally don't change the action space, but I believe you could using SageMaker.
Right on. This one came over as well. I think it's really interesting. It has a couple different parts. Is the model trained on one track only and used to race on multiple tracks? Or can the model be trained on multiple tracks? Or do people train on the track specifically used for the target race? I think this talks a little bit to best practices.
Yeah, interesting question, because the answer to all of that is yes. So is the model trained on one track only? If you think about it, the model is going to get really good at doing one particular track if you train on that track. Now, generally in machine learning, what we want to do is not overtrain a model, because that'd be like teaching your dog to only sit when it's in the kitchen. That's really overtrained. You can make it so that if you train a track or you train a car on an oval track, it's only going to know about left turns. And so if you put it on a track that's a little bit more, has more variety in left and right turns, it's not going to do well. So that car would be overtrained on that given track. So for purposes of winning DeepRacer, you probably want to optimize the car for a given track. And it kind of depends. If we come up with a virtual race for next month, we could have a very different shaped track. So if you're trained on the reInvent 2018 track, it might not perform very well. So can you run on multiple tracks? You absolutely can. One of the things I've tried a number of times, and I get reasonably good results, but not the optimal result, is I've taken a single model, I've trained it on the reInvent 2018 track for a couple of hours. I've cloned it and I've trained on a different track for an hour. I cloned it again and trained on a different track for an hour. And what I'm contending by doing that is that model will generalize better to an average track. It may not run better on the reInvent 2018 track or any given track, but the weights will be such that it will actually perform better on average on all tracks. And when we think about real life problems, you probably, if you're running robots in a factory, you probably don't want to make them run only a certain kind of pattern. You want them to deal with, oh, maybe other robots are on the floor or people are walking around or a delivery was made and now somebody set a bunch of pallets in the way of the robot. So you want to make it a much more general model. I hope that answered the question.
Yeah, and I think, is a good little bit of a follow-up there too. How does that reconcile with the race line? I guess the question is also too, how do people know the race line in advance without knowing the track?
Well, they wouldn't. So the race line has to develop through trial and error and inspection, much like you saw with the image where I showed all the dotted lines. People who are looking at a race line and, let's say that we come out with a new track for the September race. I don't even know what that track is going to be. So what would happen is people would train their model and evaluate it on that track, look at the logs to figure out what the optimal racing line is, modify the reward function to minimize the amount of distance that's going around and increase the speed, and then submit later on in that month against that particular track. So racing lines are specific to a track. And just like a NASCAR driver would do before they go to Daytona or something, they're going to go drive that track a bunch of times to get a feel for what that race line would be. Well, we can't drive the car ourselves, but we can train a model to go around it and then look at how we optimize the reward function to improve on that race line.
Tim, a couple more questions. And one thing that I want to note, I think now I know why my dog only sits in the kitchen due to overtraining. Yeah. So thanks for that.
Yeah.
One more thing for you. So why not just program the model specifically to the track?
Interesting question. That comes up all the time. So one of the purposes, remember this is an introduction to machine learning. And if you're trying to train a model using reinforcement learning to know how to do certain kinds of actions, it's not always going to work in that same fixed environment. There have been a number of people who have done things like using Photoshop. They've actually created a picture of the track and they've mapped the exact race line that needs to go around that track, and they've uploaded that into S3 buckets and then calculated during the race exactly what the optimal line around the track is. One of the things we will do is we will say during a virtual event or a physical event, when you show up at reInvent or one of the summits, you won't have access to those S3 buckets anymore. So you can't cheat it. We're going to take our car and put your model on our car. The second thing that happens is if you specifically train a model to go around a highly refined track, and you train and train and train for dozens of hours, let's say, then all of a sudden the track shows up and there's a wrinkle in it, or someone stood inside the camera lens with a pair of blue jeans on, or there's a shadow that's going across the track from lights in the arena. All of those things will cause disruption to a highly trained model. So generalizing in a lot of cases can be better. Now, having said that, I can tell you, watching all the elite racers last year, the people who were the top 5 or 10 people at reInvent, they optimized their models for a very specific track. But we didn't tell you what that track was going to be until you showed up at reInvent.
We have time for one more. And so this one is, can you tell me more about building your own track? Are there best practices?
We have, I didn't actually produce that link, I think, in the references, but if you search for it, we have all kinds of instructions on GitHub on how to produce a track. And there are companies all around, I know the United States, North America, but probably overseas as well, that actually will print up a track for you. Now, when I built the one in my garage, I did it on the cheap. I used duct tape for both the sidewall and the center line. And I used white bedroom sheets that I stole from our guest room and put those around the track, and it worked just fine. So yeah, you can build something temporary. We've even done duct tape in the office from time to time where we're training the car to go around the office. So yeah, you don't need to spend a lot of money on a track, but if you have a corporate event and you want to spend a little money, some people have gone down to one of their home supply stores, bought a bunch of plastic pipe and sewed up their own track walls and that sort of thing. So there's any number of ways you can do this. I would strongly encourage you to join the DeepRacer Club, DeepRacer IO. There's a whole Slack channel dedicated to just building tracks.
And I think the only piece that I would add to that would be ensuring that you check with your spouse or your partner to ensure that you stay in their good graces.
Agreed.
So Tim, I appreciate you taking the time today. That's all the time we have for questions today. Again, thank you for all of your questions. So as we close, I just want to kind of move up to a few small housekeeping items. Coming up on September 22nd, we have Greg Prisby, who will talk us through AWS DeepRacer Winner Circle, the future of AWS DeepRacer, and the next steps to advance RL skills. Of course, lastly, remember we are running a raffle for AWS DeepRacer car, and Pluralsight will follow up with the winner of the raffle via email in the next 24 hours. And certainly last but not least, Pluralsight Live is virtual and coming to you live from a planet that you know and love, Earth, on October 13th through October 15th. So be sure to sign up and attend. It's going to be fantastic. And lastly, always, big thanks for the questions. Big thanks for being attentive. And I look forward to seeing you all on September 22nd. Take care, everyone.